It's my pleasure in introducing David Arditi this week, the director of the BAA Equipment and Techniques section, and he'll be giving us Venus Live tonight. We will be recording the session, and it's also going live onto YouTube, and we'll be doing Q&A at the end. I'll just hand over to David now.
Thank you very much, Andrew. Thank you very much. Details of Comet Atlas, which we hear is actually rather faded since he made that presentation, and may be in the process of having some sort of disintegration event. So that's quite interesting. Anyway, I'm trying something slightly different this week. Rather than giving a presentation in a style of showing the slides, I thought I would show you what is actually going on in my observatory. That is where I am. I'm authentically isolating. I'm very isolated here. I'm at the bottom of a 30-meter long garden in suburban outer London. I am in a shed, and this shed is next to my telescope. I won't show you the telescope, but the telescope is a few meters away from me in this direction, and it is in a runoff roof shed. That is a shed where the roof is on rails, and the roof is on wheels on rails, and the roof comes off, and there's a big telescope in there. The telescope I'll be using is in fact 14-inch Celestron Schmidt-Cassegrain telescope. And if you want to know more about that hardware, I have made a video which is also on the BAA YouTube channel, showing the equipment and showing me going through some of the same things I hope to be doing today in regard of Venus. So a few introductory words about Venus for those who are not very familiar with the subject. At the moment, there's a tremendously bright object in the evening sky, and that is Venus, and it has its best apparition for many years from the United Kingdom. Venus, as you know, is an inferior planet. It is closer to the sun than the Earth is, so it's always close to the sun in the sky. It can't get more than about 60 degrees away from the sun in the sky. So to see Venus clearly, we need to get occasions when it has what we call a large elongation, that is, it's way out from the sun. And we also need occasions when it's doing that, when it's high in the UK skies, and that hasn't happened for many years. And this year we have a fantastic apparition, a fantastic easterly elongation of Venus. And Venus is visible in broad daylight. If you've got a very clear sky, it's visible before sunset, even to the naked eye. It's magnitude -4.5, and it is setting around about, or getting on for midnight. So it's in the sky for a long time, and it's currently a crescent phase. Now, I've currently got the telescope pointed at Venus. What I've got is a small camera on the end of the telescope. It is a point grey grasshopper camera. It's a monochrome camera, and it is equipped with a filter wheel which exchanges different filters in the path of the camera. And I've got a wire leading from that USB camera all the way from the observatory, well, it's just about 10 meters to where I am in the shed. And if I now share the view of my computer screen, which I should be able to do through Zoom by sharing my screen, and it gives me some options here. So I will share the whole screen so I can show you whatever is there. And let's see what happens. So now you should be able to see my screen on my laptop in my warm room shed, and you should be able to see Venus. And you'll see Venus is jumping up and down a bit. Now, why is it doing that? Well, it's partly atmospheric seeing, but it's also the traffic on this road. Although it's quite a long way away, it's about 50 meters away. When I can hear that when a bus or a lorry goes past, Venus jumps up and down, and you will see that quite a bit. So I don't have that fantastic conditions here, but we are lucky. It is clear, and there is Venus. And this is an unfiltered view of Venus. The sky, well, the sky isn't perfectly clear. It's somewhat hazy, so it's not as bright as I would hope. So other things I'll show you in this desktop. This little panel on the left-hand side, this is the control panel for the telescope. It's a telescope with an astrophysics mount, and the mount is computerized, so it's a go-to mount. And I've got a serial connection going from the observatory into this shed, and I can control it from here. And I'll show you that. If I press one of the control buttons, you'll see Venus moving around. So I can fine-tune exactly where the telescope is pointed to. And in fact, if I wanted to, I could point it to a completely different part of the sky, but we'll keep it on Venus. So another thing, another part of the screen here is this capture screen. This is this screen that's showing Venus. This is software called Fire Capture, and you can actually download this software for free. It is a very good capture software for the cameras that amateur planetary imagers use, and it works with all the main brands of cameras, the ZWO cameras and the point grey cameras, and it has lots of options which are ideally what you need for planetary imaging. So, for example, you can change the exposure length. So I'll show the change in exposure length. So I'll reduce the exposure. There, it's getting fainter. It's getting brighter as I increase it, and I can also change the gain. And that's a bit overexposed. Now, if you look at this part of the screen, this is called the histogram, and this shows you the distribution of the brightness levels. And you see the brightness levels are now going off the top of the range, so that is overexposed. You can see that's overexposed. Now, actually, we're not viewing Venus at full scale at the moment. I've got it on 66% scale, just to make it easier to find and easier to keep in the frame. Although the tracking on this mount is very accurate, so it's not difficult to keep it there. I'll show it 100%. So this is actually the prime focus view of Venus, and I'll center it up a bit better. And this is the unfiltered view. It's not very well in focus at the moment, but I can actually focus it from with this remote system. There is an option in the mount control panel to send signals to a motorized focuser. It's a simple one. It's a DC motorized focuser. And if I press these buttons to make the so I've moved the focus in, and that is more in focus now, definitely. I'll carry on moving it in, and it goes through focus and comes out, it's slightly unfocused. I mean, it's never going to be tremendously sharp because this is the real scene that we've got here. And so it's a bit of an art to get it as sharp as possible. And this is a monocolor of sky, of a particular color in Venus. But this shows you approximately what you would see through a telescope, through a large telescope under a high magnification, say 200 times magnification. You would see Venus. It would be this like a 45% crescent, and you would see maybe some very subtle markings, like it's subtly darker in the upper part, which is actually the northern hemisphere, because I got this inverted, and there's also more brightness, slightly more brightness around the polar cusps. And the focus probably is likely to change all the time, actually, because the telescope is cooling down, so it's contracting, so the focus will change. And it's hard to maintain a consistent focus also because the atmosphere affects it. So I was showing the fire capture screen. So this gives you options for not only changing the exposure and so forth, but it allows you to program in a certain length of video. So to explain that, the way we do high resolution planetary imaging is that we take a video stream, and this generates thousands of images potentially. And these images are very short. The exposures are milliseconds, are maybe, well, between 10 and 100 milliseconds typically, depending on the object and the filters we're using. And so we capture thousands of frames. and then we process those thousands of frames. So those thousands of frames are all slightly different, as you see. Some of them will be sharp, some of them will be blurred, they will have different seeing distortions within them. And when we collect those frames, and they have to be collected, the computer has to be capable of collecting them very quickly. They're immediately saved to hard disk or to a solid state drive. And when we process them, we're actually able to set software going on the images that will extract out the sharpest frames, or a certain proportion of the frames, or we could take all of the frames and combine them. They are stacked together, they are registered and stacked, they are combined together into one final image. And I hope to show you that process. So the final image that we get will be a composite. It will be a still image composed, which was constructed from a video of many thousands of frames. And that will still be quite a blurred image. But the interesting part of it, and this technique, by the way, is what we call, it's sometimes called lucky imaging or webcam imaging, fast frame rate imaging, or high resolution planetary imaging. The interesting thing is the image that you get out of the stack contains a lot of hidden information. In itself, it looks quite blurred initially, but it contains hidden information that can be processed to bring out that information. And the main method of processing that we use is called wavelet sharpening, or deconvolution, as sometimes called, and I may be able to show you that. So this is the live image of Venus. Venus is about 40 degrees high in the sky, so it's very good, a very good altitude. It's also viewed through a dispersion corrector, which is another piece of equipment which corrects for the atmospheric spreading out of the different frequencies of light, although that's not particularly important at the moment because it is reasonably high. So the software allows us to set a particular length of capture or a particular sequence of captures, and to do that. And it also allows us to set up different filters with different exposures. And so this is the unfiltered image, but I will now change the filter. So I've got a button here that I can press, and that sends a signal to an electronic filter wheel to change the filter. So it will go dark for a moment, hopefully, if this works. Oh, it didn't work. But it's always going to be something that doesn't work. I'll try triggering that from the observatory instead. I'll be back in a moment. Sorry about that slight interruption, Flo. Actually, it is a problem. It is a problem because what's happened, the reason why the filter didn't change was that, as far as I can see, one of the power supplies in the observatory has failed. There's two power supplies. There's one that's connected to the telescope mount and another that's connected to other equipment, including the filter wheel. And I just tried switching that power supply off and on, and it was completely dead. The light wasn't on. So that seems to be why the filter wheel doesn't change away from whatever setting it's on, which I'm not quite sure what setting it is on now. So I think we'll just have to work around that. That power supply has been there for about 15 years working successfully, and it has just chosen tonight to stop working. So isn't that curious? But luckily, it's not the power supply that is driving the telescope, that's powering the telescope. That one is still okay. So is there another solution to that? Let me think.
I would think, David, I'd think carry on as per the rest of it.
Yes.
And
Yeah.
when we move on to Q&A, if we have some of the other couple of people who might do Q&As, then whilst they do that, you could always have another look to see if there's anything.
Yes. Anyway, what I was going to show you is the actual process of, let's see, what's the time? It's 15:15. What I'm going to show you now is the process of capturing this image. So I'll get it in the middle. And you don't want to capture too large. This is quite a large camera frame, quite a large CCD chip. So I can reduce it down. I can draw in this file capture software, I can draw a box around Venus, and I can reduce the area of interest to about 400 by 350 pixels. Click OK on that. And so there we've got a smaller image of Venus. I'm doing that so as not to record too much data, because you can potentially gather gigabytes of data. I'll just see if the...
And just let you know one thing, David, we can hear you, but occasionally you're going a bit crackly. If we lose you completely at any point, I'll let you know. But I think it's good enough, and I expect it's because you're outside in your observatory where the signal to your home router might not be so strong.
Could be. So we can set the video capture to be a certain length. So I'll set a short video capture. I'll set it to 30 seconds. Set it to 30 seconds. And so, yeah, now it's limited to 30 seconds. And the type of file we're recording is an SDR file. The options are SDR files and AVI files. But we could record the SDR file. And other information here, I can see that we're getting about 119 frames per second. And this software also shows how much space there is left on the hard disk, how much RAM is being used in various bits and bobs. So I'll now capture the image. So I'll press the red button and it is now recording the image. And these numbers at the top of the screen show you how many seconds the recording has taken and also how many frames it's been taken. The L means it's a luminance or an unfiltered image. And the frames per second are the other number. So it's the order of 120 frames per second. And there it's going. And now it will finish. And so we've now recorded our video. And I will now show you briefly the processing of that video. So I will move over to a program which is the one that is usually used these days for this purpose. Here, by the way, some images I took earlier, just in case I couldn't succeed in taking any today. And this shows Venus and various filters after processing. Here's an infrared image. This was some time ago, it was about a month ago, when Venus was gibbous. And this is more of a heavily processed in the middle, more of a heavily processed infrared image. And this shows you some of the characteristic markings that we see on Venus. This is called the psi shape, this kind of fork shape. And this is in the clouds. So to anybody who's not very familiar with Venus, I want to explain that what we see with Venus is not a solid surface. We see the top of a very thick atmosphere. Venus is a hot planet. It's about 400 degrees Celsius on the surface. It is hot enough to melt lead. It has a very thick carbon dioxide atmosphere, and it has sulfuric acid clouds. And we see the top of that atmosphere. And using the various filters that we use, we can examine different depths of the atmosphere. And the ultraviolet and the blue end of the spectrum tends to, we believe, corresponds to a higher level in the atmosphere. And we probe deeper into the atmosphere and even down to the surface using the longer infrared wavelength. So this middle image shows some of the markings in infrared. And then on the right-hand side, there's the more blurred looking ultraviolet image with some of the characteristic cloud patterns, including the brighter polar cusps. So the next thing I'm going to show you is the AutoStackert software, AutoStackert, which is software written by Emil Kreykamp, who is a good friend of the BAA. And he's also made this software freely available. And this is the software for processing the image. By the way, I was organizing through my committee on the equipment and techniques section was organizing a workshop to take place it was going to take place in June, a workshop on planetary imaging, advanced planetary imaging, which was to take place in the Institute of Physics in London. Obviously, with the current situation, we've had to postpone that, but we do hope to be doing that at some stage in the future, maybe later this year, or maybe it'll have to be next year. But that, when we can arrange meetings again, that will be in the BAA calendar, and myself and a number of very accomplished amateur planetary imagers, such as Damien Peach and Martin Lewis, who we should be able to hear from in this webinar later, hopefully. They will be giving talks and presentations when we can do that. So this whole thing, this whole webinar is a little bit of a substitute for that, because we can't do that. So I keep sidetracking myself. So I'm going to look at that video that I've just captured. So I'm going to find it. So I find it in the file structure. So one useful thing about the capture software, the file capture software, is that it does allow you to name these files methodically. So I've set it up to name the files by the object and by the date and time they were taken. So all that information is in the file name, so it can't possibly get lost. So we've got the correct images and we've got the correct details. So I'm looking in the Venus file. Taken today was taken 2020 04 07 now, isn't it? No, 2020 04 08. There it is, and there is the SIR file. So I open that SIR file, and this window on the right, this displays, I think it's the first image in the set of images. And so I'll show you some of the settings that we need to use in this AutoStackert. We have the main window of AutoStackert is this left-hand window. And after we've opened the image, we can choose either a surface or a planet. And surface is good for the moon and for the sun, but we want the planet setting. So we set it to planet. And then you have various options for the quality estimate, for estimating the quality estimator. And if I choose the edge, then I get a graphic with a planet, and I can define where the limb of the planet is. And it says disable the shadow side of the planet. So I've done that, I've disabled the shadow side of the planet. And I'll now ask it to analyze that data that we've collected. And so it is analyzing the data. And I'll drink some tea. There is, in that video, there is 3,500 frames approximately, and it produces this quality graph, and it's telling me that it makes an attempt to measure the sharpness of the images, basically. It can't do that perfectly. Well, it does its best, but and there are various ways of defining the sharpness of the image, obviously, so it's now able to order the frames in order of quality. And it's showing me that there's a proportion of the frames which are above what it's estimated as 50% quality. About a quarter of the frames it's estimating are above 50% quality. So I'm going to ask it to stack a certain number of frames. I'll ask it to stack 25% of the frames. And this is this green box here. It has other options. You can ask it to enlarge the image by drizzling it, but I won't ask for that. You can ask it to sharpen the image, but I won't ask it to do that. What you have to do is, before it goes any further, you have to give it an alignment point or an alignment box, and you can choose different sizes of alignment boxes. So if you choose the 100 box and just click on the middle of the planet, I get a box there. You can do more than one box, but I find it's not particularly beneficial with Venus, so I won't do more than one alignment box, but just leave it like that. And I will, and at this stage, the stack button becomes available, so I'm able to press that, and it will now start the process of stacking. And this takes this computer. Oh, it's done it already. That's quite quick. So it's now stacked the images. We can't see them, we can't see the stack, but I will open them in another program. I've got a copy of Registack 6 here, which is quite an old image stacking and processing program, but it has useful functions in it still. And this will enable me to open up this stacked image. So I will look for this stacked image. So I'll look for my Venus images, and I will look for the one taken today on the 8th. And it is stored in a folder which has a suffix of 25 because an ASP25 auto stacker generated this folder, and it is stacked the best 25% of frames. And the result of that stacking was that image there. That image there. So that is essentially the stacked but unprocessed image. So the main usefulness these days of this Registax program is these wavelet sliders, which allow you to sharpen on different scales, enhance the contrast on different scales, and you can experiment with what these do. And different people will have their own different preferences, and it will also depend on your equipment, the focal length of your equipment, and how many frames you're able to take, and characteristics of the camera, and this and that. So if I move this wavelet number 1 slider across, well, nothing appears to happen. If I click the do all button, well, nothing much happens. So let's try, if I right click on that, that goes back to 0. If I move the number 2 across, let's see what that does. And that does a bit of a sharpening. It exaggerates the contrast, and you can see there is a bit of contrast there. There's some cloud detail there. In fact, I think it's getting a bit grainy there, so I'll do that a bit less. And so there is a sharpened image. I think this is, because the filter wheel isn't working, I'm not quite sure what the filter was, but I think that is probably the unfiltered image of Venus. And you can see some subtle details there. As I said, we tend to image it with filters, often with monochrome cameras. You can use color cameras as well. We tend to use monochrome cameras because they are more sensitive to the extreme end of the spectrum, to the infrared and the ultraviolet. And we see, as I mentioned, different levels of the atmosphere in different wavelengths. And these filters are quite reasonably priced now, quite easy to obtain for amateurs. And another type of imaging of Venus we can do is further into the infrared. The infrared filter that I would have used tonight, if the filter will have been working, would have been about 800 nanometers. But we can use filters around 1,000 nanometers as well. The cameras are much less sensitive at that wavelength, but we can use them. And the usefulness of this is that there is a window of transparency of the Venusian atmosphere at about 1,000 nanometers. And this actually allows us to get a signal from the surface. And this can be done when Venus is a very thin crescent. Now, it isn't a thin enough crescent at the moment. It needs to get really thin, and that will happen in May sometime. And so I and other observers will be doing that in May. When Venus gets to a very thin crescent, we will be imaging at long wavelength, around 1,000 nanometers, and we will be seeing if we can detect the thermal emission from the surface. And the thermal emission from the surface has signal in it, which represents the state of cooling of the surface. And it shows us the topography. And so this is quite a new technique, and it's one that we have to see whether we can exploit it to discover anything new. But there have been some interesting results from various observers around the world, particularly Anthony Wesley and his collaborators in Australia, and things have been published on that in the BAA journal. And of course, you'll find details of that kind of thing on the BAA Mercury and Venus section pages. So imaging of the surface under very particular conditions is possible, and those very particular conditions will come about in a few weeks' time. So when we've got our image, the other thing to do with it is save it. So I'll save that image now. So you click save, and I can give it a new file name and save it alongside the unprocessed image. So I've shown you the I've shown you that one, and here's a more scenic shot of Venus, showing how it appears in the evening sky at the moment. Well, the moon is not there now. The moon has moved around to the other side of the sky and was full last night. But Venus is really spectacular object. It's attracting everybody's attention. Everybody is asking you, if you're an astronomer, what is that thing in the western sky? Viewed visually through a telescope, it's fairly plain. You just see the phase, but some people use violet filters, and some people with eyes that are good at the violet end of the spectrum can pick up quite a bit of detail. Paul Abel has been doing some excellent drawings recently, visually through violet filters and other filters, which show the same kind of markings that we can image. And a more recent close-up image of Venus when it was just a crescent phase on March the 25th. And there you can see in the infrared image, you get a kind of mottling effect, and then you get a more of a general, you get these broader cloud shapes in the ultraviolet. And these cloud shapes are fairly fixed. There is a rotation period of the upper atmosphere, which is completely different to the rotation period of the surface. The rotation period of the upper atmosphere is 4 days. And so you can follow this round, and you can see the same features in the upper atmosphere coming round in the ultraviolet. So you can imagine that the winds on Venus are absolutely terrific. There's this terrific wind gradient in the atmosphere, since the rotation of the surface is can't remember, a couple of 100 days, something like that. So but the upper atmosphere is rotating so fast, and it sets up these permanent waves in the upper atmosphere, which give rise to these markings that we see in the ultraviolet. But it's not completely understood, so it is an area where amateur observations are still valuable, and they contribute to the knowledge of the planet. They're of interest to the researchers analysing the data from the probes that have gone there, such as the ESA probe, the Venus Express probe, which was there a couple of years ago. So there is a significant amateur-pro collaboration sharing observations of Venus. So I've now rattled on quite a long time, for about 25 minutes. So it's high time that we looked at what questions have come up. And I've got, I believe, Martin Lewis and probably Damien Peach as well, who will be able to speak and possibly answer some questions. So now I have to find,
David,
yes.
What I'll do is I'm just going to, Damien, I'm just going to click you to allow you to talk. So this will, this should, I think, now your microphone should now be on, and you'll be able to mute and unmute yourself at will. I was looking for Martin Lewis, and I thought I saw him earlier, but I don't see him on the list. There is a Martin there. Martin, I don't know if you can just type in the chat to say whether you are on, or otherwise raise your hand.
Now, shall I stop sharing my screen? Would that be better? We've got a question here from Peter Sherman. What make and size of telescope are you using? It is a Celestron 14-inch. It's C14. It's on an Astrophysics 1200 GTO mount. I emphasize that fact because the mount is really the most, in my opinion, the mount is the most important part of the system. An accurate and reliable mount makes all kinds of observation much, much easier. And I can do not only planetary imaging with this system, but also deep sky imaging. So it's a standard commercial telescope. One characteristic of Schmidt-Cassegrain telescopes is they have glass in them. Obviously, they have an optical window, is a corrector plate, in fact, at the front, and that takes away some of your ultraviolet light. So arguably, it's not an optimal telescope for imaging Venus in the ultraviolet because the anti-reflective coating on the corrector plate will actually considerably reduce the ultraviolet getting in there. Having said that, since it's a big aperture, 14-inch, you gain that way anyway. And also the correction isn't perfect in the ultraviolet. The Celestron design, the Schmidt-Cassegrain design, has spherical optics, and then the aberration in the spherical optics is corrected with the corrector plate, but that can only be done perfectly for one wavelength, and they perfect that for red light. In fact, it's the light of a neon laser. So it's way out, the correction is way out at the ultraviolet, in the ultraviolet, because they never considered that would be a thing that people wanted to do, but now we can image in the ultraviolet. So the images are never that sharp in the ultraviolet, and arguably a completely reflective, or most probably a completely reflective system like a Newtonian reflector would be better for ultraviolet imaging. So that's the type of telescope. It is a Schmidt-Cassegrain, and I'm using it at prime focus. So there's no Barlow lens in there. I've chosen not to put a Barlow lens in because that would also absorb more of the ultraviolet. That would reject more of it because it would have more anti-reflective coatings. Why? And we got another question, which is why.
David, I'm just going to. Martin is Martin Lewis. I'm just going to allow him to talk. So Martin, I'm just going to flick now, and you will be unmuted. Or actually, no, I think you are muted, but you'll be able to mute and unmute yourself now at will. Thank you.
Hello.
Hello, Martin. Nice to hear from you.
Hi, good. Glad you're receiving me.
Martin is an expert telescope builder. He's built his own telescopes, including an 18.5-inch Dobsonian, which is the one that he regularly uses to get very impressive images of Venus, which would seem to argue that it is the case that perhaps the Newtonian reflector is the best system for imaging Venus in these various wavelengths because it has equally good optics for all frequencies. What would you say about that speculation, Martin?
Yes, certainly in Newtonian, you're not going to get any absorption from the mirrors like you would with an SCT that might have multi-coatings on the corrector plate. The Barlow I use and the ADC I use do seem to be pretty transmitting in the ultraviolet light. The ADC, which corrects for dispersion in the atmosphere that tends to stretch stars and planets into a sort of rainbow colors, is Piero Astro, and that has got coatings on it which extend into the ultraviolet, which helps. But even cheaper ADCs like the ZWO are perfectly usable in the ultraviolet. They might absorb by 20–25%, but are perfectly usable to see these cloud details. Barlows, the Barlow I got that I'm using is an APM Barlow, and seems to work very well in the ultraviolet. I can't vouch for other Barlows, but certainly with a Newtonian, the main optics will be, you won't have an issue with that, but you do need to think about ADC and other refracting components that might be in the optical path.
Yeah, another point is the ADC has to be adjusted right, which is quite a fiddly process. An ADC is a pair of prisms, essentially, and they're rotatable with respect to one another. And the best source of information is actually Martin Lewis's website, skyinspector.co.uk. He's got a whole page or article there about adjusting an ADC. And so that's worth a look if you want to get one, because the lower down in the atmosphere, the more extreme the correction needs to be. So the wider apart the setting of the two prisms needs to be. But the correction also needs to be in the correct plane. It needs to be perpendicular to the horizon. And if you've got an equatorially mounted telescope, as I have, then that's going to keep changing as Venus is setting. The angle of the telescope to the horizon changes. So in theory, you'd have to keep altering the setting of the ADC as well. Having said that, I haven't really bothered experimenting with the ADC tonight very much. I've got it on a setting which seems to have worked for well enough for the last few weeks, so I haven't touched it. So that's that hardware aspect. We've got a question now about the file format from Mr. Duffy. Why an SCR file and not an AVI? Actually, I haven't got a clue, so I'm going to ask somebody else. Are you there, Damien?
Hello.
Hello, Damien. How
Hiya.
are you?
Yeah, I'm good, thank you. You?
Yes, I'm very well, thank you. I'm very busy doing all these activities on Zoom, replacing meetings that we've had to cancel.
All right.
So, yeah, and I'm spending a lot of time down this end of the garden in this in the summer house, which is quite quiet. But the neighbours are lighting a lot of bonfires at the moment. They've decided the period of isolation is an opportunity to have loads of barbecues, bonfires, parties. So there's a lot of smoke all the time.
Brilliant.
Which is annoying me. Anyway, what somebody has asked is about SCR files. Do you know about this? What an SCR file really is supposed to do, and why this is a good thing to use?
SCR format came in, I think it was originally with Luminera cameras several years ago now, and it's just a form of uncompressed video. With AVI, you can often have forms of compression on the video stream, but these days, typically, you can capture in either format in uncompressed. So in real terms, when it comes to capturing, whether it's AVI or SCR, you know, it's far more important that obviously you have good seeing and good collimation, etc. These things are probably far more critical than whether I should be capturing an SCR or AVI.
Yeah, I suspect that's right. I do remember reading somewhere that AVI wasn't a very fixed standard. I think
that's right.
Different programs record different formats and call it AVI. Yes. So the SCR was introduced in certain pieces of Astro software to try and create an exact standard.
Yeah.
David?
Yes, Martin.
Can I chip in here? So yeah. I'm using SCR all the time. One of the big advantages of using SCR, there are a couple of advantages. One of the big advantages is that you can use SCR Player to view the video afterwards, which is a really convenient way of viewing a video and stopping it, chopping it, and advancing through it frame by frame. So SCR Player is written by Chris Gary, who wrote the PIP program, which is sort of the Swiss Army knife of video processing. Allows you to do all sorts of things with video data. So if you record in SCR, then you can use the SCR Player, which is a really big advantage. One of the things with SCR files is that each frame has got a timestamp built into it, which AVI files don't have. And that can be quite useful for reconstructing things afterwards. And so if you quality sort a video, it will still retain the original timestamp of that individual frame, which can be helpful sometimes. But the SCR player, which is a free download, is really useful for viewing your video afterwards.
Yes, the SCR file is not read by many different pieces of software. It's not generally usable on Windows. If you double click an SCR file, it won't do anything. It has to be this other piece of software Martin mentioned, PIP, the Planetary Imaging Pre-Processor by Chris Gary, that will convert to AVI files, and then you can play them in the normal way on Windows. But it's a program that's SCR is only recognized by a few bits of software. Now the next question from Peter Willems is, how do you choose the gain, exposure and gamma and for best processing? Well, that is a very good question because it's quite a controversial subject. If you increase the gain, then that allows you to reduce the exposure. So in a given length of time, that will allow you to capture more images. And in general, we find if we have a stack of more images, we can apply more sharpening, more extreme processing, and we can extract more information out of them. We get more sharp frames. So from that point of view, increasing the gain would seem to be very beneficial. But of course, increasing the gain leads to more of the random thermal noise in the image. These kind of cameras that we're using are not cooled, and you do have noise in them, although it doesn't become an issue except for longer exposures like you might use on Uranus, for example. But on the short exposures we're using for Venus, we don't bother. I don't know of anybody who bothers to, for example, we can take dark frames, but I don't bother to do that. So gain and exposure, yes, this is the thing that, well, in this workshop which we were trying to organize, I think we actually had a talk about this. Somebody was actually going to analyze this. So, and I think Martin has actually analyzed this subject, and he will now reveal the answer.
Well, the answer is, don't worry about it. So I used to fret endlessly about, was I using the right gain and exposure combination? Should I be using a higher gain and a shorter exposure, or a lower gain and a longer exposure? And what really matters, and this gets to the heart of lucky imaging, is that essentially lucky imaging is a very long exposure made up of lots of short exposures. So because you can stack and align each short exposure, you overcome the smearing effects of the atmosphere, and the very long exposure allows you to reduce noise levels. Each frame might be quite noisy, but add them all together and you end up with a long exposure. The noise averages out, and that allows you to do this amazing stretching and contrast enhancement that you can do with wavelet processing and other forms of contrast enhancement. And what's interesting is that if you use a high gain and a short exposure, or a low gain and a long exposure, if you add them all together, what really matters is the accumulated exposure time. So if you halve the exposure time and double the gain, so you end up with the same brightness, you'll get twice as many frames. So it all comes out in the wash. What matters is not exactly what gain and what exposure you use, but the total accumulated time from the point of view of noise. But obviously what matters from the point of view of atmospheric smearing is you don't want too long an exposure. So shorten the exposure and increase the gain, and that will reduce the smearing. And as long as you're not dropping frames because your exposure is very short and you've got a very high frame rate that your laptop or your hard drive can't cope with, you'll win out, because the shorter exposure will reduce, you won't get that so much smearing. So hopefully that is a brief overview of the solution to that problem. Don't worry about it, because the exact gain and the exact exposure don't matter, as long as what matters is the total accumulated time from the point of view of noise.
I'll say that I've been experimenting with this in the last few days. I was imaging Venus in the ultraviolet with the gain set to the low end, and I was imaging routinely for 244 minutes, and I was collecting something of the order of 10,000 frames and processing that. And in the last few days, I've decided, well, let's try putting the gain up really high and reducing the exposure, so we get the same levels. We get the histogram about 75% full, and then in the 4 minutes, I've been capturing about 60,000 frames. So the problem there is running out of hard disk space very quickly. But the result did seem to be better with those 60,000 frames at the high gain. It was about 75% of the maximum. Then the result seemed to be better than I was getting when I was taking fewer frames at lower gain. So it's a thing you can experiment with. But there doesn't seem to be a right answer. As regards with gamma, again, I don't know. This camera that I'm been using today, the gamma doesn't seem to be alterable anyway by the interface given in fire capture for some reason. So maybe it just isn't in the hardware of the camera. But some cameras, the ZWO cameras, definitely they do have a gamma function which can be altered in the fire capture software.
Yeah, I wouldn't. Can I?
Yeah.
Sorry, can I interrupt?
Yes.
Yeah, I wouldn't recommend using gamma. If you do have the gamma ticked, what you'll find if you look at the histogram is you will get holes in the data. So it will chop out chunks of your data in order to compress it at the top end or the bottom end, depending on what your gamma is. So it's much better to leave the gamma unticked and keep all your data and do any gamma correction later on.
I'll ask Damien if he has any particular rule of thumb that he uses about gain and exposure and gamma for Venus.
I would say in particular with gamma, I'd kind of echo what Martin said there. It's best just to leave that at the default value because you can end up with various spurious effects later on when you've stacked the images. If you play around with the gamma, there is actually a function in fire capture where you can alter the screen preview. So it doesn't actually affect the data, but will affect the live on-screen image, and kind of dropping the preview gamma down can actually kind of help you with focusing on objects like Jupiter, which is, you know, generally low contrast atmospheric detail that you're focusing on. I often use that screen command in fire capture where you can, as I say, adjust the preview brightness and gamma when I'm focusing. So I do use that sometimes, but generally I would say with gamma, just leaving it unticked to keep it at the default value. With exposure and gain, and one thing you do have to watch out for is that I've often found when you use, for example, very low gain settings, you can sometimes end up with the weird onion skin effect in the image when you've stacked the frames together.
Yeah, that is one of the artifacts that you see sometimes.
Yes, I've definitely seen far more trouble from using too low a gain than using too high a gain. Obviously, if you go too far, then stacking programs might have trouble with a very noisy image in working with it. But yeah, you can get all these weird artifacts creeping in with too low a gain. I wondered, David, whether you wanted to just click on the on-screen gamma button to show the viewers. So right at the top of the screen next to the 100% value.
Yeah, yeah, that's the one.
So right in the middle, move your cursor up onto the middle. To the left of that, immediately to the left of that button there, that. If you click on that,
screen adjustments.
Yeah.
and that will enable you to have to adjust just the preview. Doesn't affect the recording. Quite useful. That's what Damien was talking about.
Yeah, that's really useful when it comes to focusing. I often use that.
Oh yes. Right. No, that I've learned something there, and I hadn't found that little setting there. I'll move on to the next question, which is from Jeremy. At what altitude would you need to use the ATM, the dispersion corrector, atmospheric dispersion corrector? Well, I would say with the filtered imaging that I've been attempting to do today with Venus, it doesn't make much difference because the filters, because they only allow one or a restricted range of frequencies through, there isn't going to be that much dispersion. The dispersion corrector mainly comes into its own with color imaging, where you get a really distinctive spread out of the light from red to blue, and particularly imaging Jupiter, which will be very low down this year. You'll get quite striking fringing effects without a dispersion corrector. I would say as a general rule, with a color camera, at all altitudes, probably a dispersion corrector, all altitudes that you'll get in Britain, but the planets can't go above 60 degrees from Britain. I would say with a color camera, a dispersion corrector is good at all altitudes. With the filtered imaging, I would say probably above about 30 degrees, you're unlikely to detect the effect of the dispersion corrector. It's unlikely to improve the image very much, but it also depends on which color you're dealing with. And there is in a presentation I do on this, and possibly also on Martin's site, there is a graph showing how much dispersion there is with different filters. And at the red end, there's much less dispersion within a certain bandwidth of filter. So you've got a filter which has a certain bandwidth and it's red filter, and you've got a filter which is a blue filter with the same bandwidth, then the dispersion for the blue filter will be greater, and therefore the smearing out of the image vertically in the atmosphere will be greater, and therefore the effect of the dispersion corrector on filtered imaging is more striking at the blue end of the spectrum. But whether it makes that much difference for this Venus imaging, I'm not that convinced, because we don't get very good seeing in the daytime or in the twilight generally when we're imaging Venus anyway. So I would think, and the ultraviolet image it probably is a bit improved by the use of the dispersion corrector at the altitude of Venus that I've been imaging. It was today, it was about 40 degrees, but at the infrared end of the spectrum, it will make absolutely no difference. But if you were taking a color image of Venus with color camera, yeah, it would be noticeable. The color fringing would be noticeable at 40 degrees, and you would get a better image correcting for it. So the answer is mainly color cameras benefit from the dispersion corrector. And really the reason I've got it in my imaging train today is I haven't bothered to take it out, because I want to keep a standard focus of the telescope, so I could go on to image some other object if I wanted to.
And David, just to let you know,
yes.
I can see a few questions have come in on YouTube as well. So
Really?
if we have time, once we've answered questions which have come through Zoom, I'll pass on one or two from YouTube too.
Yeah, and Damien or Martin, do you want to say anything else about the circumstances where you'd use a dispersion corrector, where you think it would be beneficial?
No, I think you've summed it up quite well there, David, really. I'm using a dispersion corrector when I'm imaging in ultraviolet light, because I know that the dispersion is much worse at the blue end, and obviously in the ultraviolet, you know, I'm expecting to see dispersion across the ultraviolet band. So I set it up anyway, but I haven't experimented with using it or not using it. And the way I set it up is that I just do it with an eyepiece. With the eyepiece, I have an eyepiece that's exactly the same focus as the camera. So I'll put the eyepiece in, adjust the levers to remove the red and blue fringing on the planet as best I can, then take the eyepiece out and put the camera in. You need to do it at the same focus setting, because the focus distance between the focal plane and the ADC does affect the setting. So it's useful to have an eyepiece, a sort of parfocal eyepiece that's parfocal with your camera for doing that.
Yeah, if you're using a color camera, you can do it directly on the screen as well. You can optimize the adjustment of your dispersion corrector by looking at the image on the screen.
That's right, yes.
Another method is to use a filter which transmits a violet image and an infrared image of a star. You look at a star, and then the images will be slightly separated. The Raton 47 filter does that. It transmits violet and infrared at the same time, and then you can adjust the dispersion corrector to bring those two images together. And that's getting into a lot of detail. So we'll move on. We'll move on to the question about, is from Dominic Ford. This is a controversial one. Is the Ashen light real or an illusion? So the Ashen light is the faint illumination of the dark side of Venus that is supposedly similar in appearance to the Earthshine seen on the moon, and it's been reported by various observers down the years. I've been looking for the Ashen light for 50 years. No, I'm not that old, 40 years, and I haven't seen it. It is, has any opinion on the Ashen light, Damien?
Well, that's a very good question. I've spoken to observers that are absolutely convinced that they have seen it. I myself, again, over many years of observing, I've never seen it myself. It's going to remain one of those kind of controversial subjects, isn't it? It's real if you've seen it yourself, if you see what I mean.
Yeah, I think the argument is that it only appears occasionally and it's only visible in a dark sky. And generally, in imaging, we're trying to get the planet high up. So we're imaging in a light sky, and many visual observers will be looking at a light sky. And one of the arguments about the Ashen light is that you need to look in a dark sky, and it doesn't happen all the time. It only happens occasionally. And there have been various theories, mechanisms suggested, one of which was lightning or some kind of auroral phenomenon in the Venusian atmosphere. This all seems to be unproven. It's unsupported by results from the space probes. The orbiters have not seen anything that corresponds to the Ashen light. There is this glow of the night side in the infrared, but which I mentioned, which is a thing that we can image, but that is a long way beyond the human eye. The human eye, that's in around 1,000 nanometers, and even a human eye is very sensitive to the red. It's not going to go much beyond 600 nanometers. So that's a long way across. So that is clearly a different. If the Ashen light exists, I believe it is different, an unrelated phenomenon, unrelated to the thermal glow of the surface. The main thing that strikes me is that people are taking a lot of images of Venus these days with all kinds of telescopes, different systems, different cameras. thousands of images and not one has clearly shown the ashen light. And I suspect if it existed, somebody would have taken a clear image of it. So that is why I'm very skeptical.
But I would have thought that, I mean, the human eye, the dynamic range of the human eye is so superior to a camera that you can imagine possibly seeing the ashen light at the same time as the crescent, whereas generally if you image, you're going to be exposing for the crescent, not overexposing it, and the ashen light, say it was 1,000 times fainter than the properly exposed crescent, you just wouldn't register on the camera. You would have to expose for the ashen light, massively overexposing the planet, which some people are doing, but the vast majority of Venus images are going to be exposed for the planet and miss something that would be as that was significantly fainter.
Yeah,
this is Andy, and I hope you don't mind, but I thought I might jump in on this because that would be an interesting challenge for our spectroscopists who are on the call. Because if it was by any chance Aurora, you could take a spectrum to then see if that, because you'd get emission lines which would jump out.
Yeah, one of these other subjects to do with Venus, another thing which has been a lot of discussion about down the years is the phase of Venus. So we can estimate the phase of Venus visually, and we can estimate it from images, and you get different results in different wavelengths. And this is quite striking in this image from March the 25th, where Venus is around dichotomy, but it's quite clearly a smaller phase in the ultraviolet. It appears smaller phase in the ultraviolet than it does in the infrared. And actually, the true dichotomy, the theoretical date of dichotomy, I can't remember. It was something like March the 17th. So it was quite close to that time. But the phase of Venus always looks less than the theoretical, than the predicted phase. And this must be something to do with the transmission of light through Venus' very thick atmosphere. And light seems to be filtered rather efficiently round the poles, and so causes effectively extension of the cusps. But it depends how long you expose it for. If you expose the ultraviolet image long, you'll get a longer phase. So it's not a clear, it's unlike the phase of the moon, which is a precise, clearly definable thing. I think the phase of Venus is not a clearly definable thing, and it has different shapes. You can see from these images, the phase has different shapes in different wavelengths on the same date, and different magnitude, both a different magnitude and a different shape. But that is another thing you can do, another project of the Mercury and Venus section, which you can do visually or through images, is to measure the phase and compare it with the predicted. So that's called the phase anomaly of Venus, or sometimes called Schroeder's effect. I'll go back to the questions. Software for Mac users. Are there suitable software options for Mac users? They're definitely restricted, more restricted than the options for PC users. I am actually a Mac user, but I deliberately had to buy a PC to use with the astronomical cameras. So most of the cameras, well, actually, I did actually, strangely enough, look up this question today. The ZWO cameras may work on Mac OS, but I haven't tested that myself. But the information that I looked up today, for a completely different reason, I was actually wanted to see if I could repurpose one of my Astro cameras for a completely different purpose. And I was wondering if I could connect it to a Mac, and the information seemed to be that it may work with a Mac. But then you have the question, do you have the capture software? It may interface with the Mac, the camera may interface with the Mac, and you may be able to get the image, but do you have effective capture software on the Mac that will allow you to capture the image with the exposure and gain settings and the details that we want. And fire capture doesn't directly work on the Mac, though you could no doubt make it run under an emulator, which is more complexity. Pretty much all the planetary imagers are using Windows systems, and there have been programs on the Mac that have done some similar things with certain cameras. I have used them in the past, but there isn't an equivalent of the stacking program. Auto Stacker also requires Windows, so unless you get into emulation, it's difficult on the Mac, because even where the cameras interface with the Mac, you might not be able to get software that is very effective. Do you have any comments on this subject, Damien? Do you know anything more? No?
Hello? Yeah, hang on.
And Andrew? Andrew? Hey, Damien or Andrew?
Yeah,
Hello, can you hear me?
I think Damien was muted and just unmuted himself.
Right.
There's probably not much I can add on that. I see Martin is muted as well, but
No, I don't have any experience of Macs at all.
No, me neither, unfortunately. Or maybe fortunately.
Yeah, I think we did ask when we met the guy who wrote the Auto Stacker software a few years back. He came to receive an award from the BAA, the Highresolution medal, and we did ask him about this, and he considered it not worth his time to put it into different operating systems. So that's the problem we've faced. These people are not being paid for it, basically, so they'll write software that is going to be usable on the most common hardware. So there may be an opportunity there for somebody to develop planetary imaging software that works well on the Mac. What advantages does Auto Stacker have over Registax or Deep Sky Stacker? I don't think Deep Sky Stacker would work well with the fast frame rate cameras. It's not designed for doing that. Deep Sky Stacker is excellent for stacking relatively small numbers of images. But I think once you've got more than 100 images, I think Deep Sky Stacker wouldn't cope very well. You can use Registax still. It is still working, as far as I know, on current Windows systems. Actually, I've got Windows 8 on this computer and it works on that. So I don't know if it's still working on Windows 10, but it is an unsupported program, Registax, and so is likely to stop working on systems sometime in the future. Damien, do you think Auto Stacker does a better job of stacking than Registax?
Yeah, I do think it does a better job, and it's kind of backed up through tests that various people have done over the years in comparing the software. And these days, generally, the vast majority of experienced planetary observers are using Auto Stacker to create the stacked images from the videos. And what they then tend to do is to move those stacked images into Registax for wavelet sharpening. So Registax kind of these days is mostly used for just sharpening the images, while Auto Stacker is used for stacking them.
Yeah, there is a sharpening option in Auto Stacker as well, and I've found that quite effective on the Moon, but less effective on Venus, where I find you need a more extreme sharpening, and you need to experiment with it. The wavelet sliders in Registax are really good because they allow you to directly see very quickly the effect of the sharpening. You can do the sharpening in other programs as well. In Photoshop, there is an unsharp masking part of the program which does a similar job. I think the GIMP, which is a cheap and all free graphics photo processing programs that does some of the same things as Photoshop. I think you can use that, and there are other astro imaging packages which have sharpening routines. But the auto stacker, it has several advantages that I can see. It will save the images with a file naming format with the time built into them in a specific way that is readable by another program that we use quite a bit, which is called WinDupos, which is a program that we use on the giant planets principally to derotate them. That is to take an image which has been exposed for a long time, during which period the planet is rotated, and we effectively unwind that rotation. And that's done by this WinDupos program, and the output for an auto stacker can be made to integrate with WinDupos quite well. And also, Simon Street has asked about which is the best dispersion corrector to use for visual work. There is quite a few makes. I did look into this recently for a presentation. There are dispersion correctors made in China now. They're sold under various brands. I think there's an Altair Astro one. There may be a GSO one, Guangshen optical one. There's the one made in France, and there's one made in Astro Systems Netherlands. I think there are about 5 different makes. They all do much the same thing. I would say any of them actually. I wouldn't say they're for visual use. I would say that, and they are good. Yeah, you do notice a difference, particularly with Jupiter. This year, definitely to look at Jupiter, I would get a dispersion corrector. I would say any of them will make a good improvement. Do you have any thoughts on makes of dispersion corrector, Damien?
I kind of agree with what you said there, to be honest, particularly visually this year with Jupiter and Saturn, with them being so low in the sky. I'd almost consider a dispersion corrector an essential piece of equipment if you're serious about trying to get some good views and images of those 2 planets from the UK. They'll make an enormous difference, not only to the image quality, but also to the views visually through the eyepiece. And in terms of which one to go for, yeah, I've tried several, and it's, just take your pick, really. I mean, the ZWO dispersion corrector, which you can pick up for around 130, 140 pounds, does a really good job.
Yeah, I tend to agree with that. I've got a ZWO ADC, which I use occasionally and performs very well, as an imaging device, as an optical device. And it is strange that ADCs do tend to be regarded as for imagers, and yet when the planets are below sort of 40 degrees, which most of the major planets are from the Northern Hemisphere at the moment, they considerably improve the view optically. You can see significantly more detail on Jupiter, Saturn, Mars, all those planets optically, and yet they are regarded mainly as a specialist item for imagers. And I'm very much an advocate for people to get one. They're not that expensive now that ZWO and China have got into the game. They were premium products, I guess, a few years back, but now they're the price of a low-end premium eyepiece, I suppose.
I mean, that's a really good point, actually, in that just remembering that they're not just accessories for imaging. They can make a really big difference to the quality of the view visually. And I've often been amazed at the difference, the view through the eyepiece when you have the ADC in compared to when you don't.
Yeah, absolutely.
Yeah, And another thing which I'll just mention, although nobody's asked about it, I'm a big advocate of bino viewers for visual planetary observing. I find I see a lot more with 2 eyes than 1, and the combination of using an ADC and a bino viewer, I think, is absolutely optimum. You do have to buy 2 sets of eyepieces, the same, of course, for that. But particularly as you get older and you get more floaters in your eyes, more defects in your eyes, that make viewing with 1 eye less good. You can still, if you use both eyes, you can get a tremendous improvement, and particularly with Jupiter. I think bino viewers are really a good accessory. Anyway, that's a different subject. Alan Buckman asked, now the temperature is going down, is the finished image more stable? Yeah, it does look quite stable actually now. It's looking at a little bit kind of fuzzy around the edges, and it's lower in the atmosphere, of course, but it does look, it's not bad. That's not bad seeing. Peter Woolham has asked, have you found autostacker sharpening? How have you found the sharpening and drizzle functions? Yeah, I have experimented with the drizzle function. Yeah, it works. It seems to work. It works, but I'm not sure it does anything different than you would get just from enlarging the image at the end. It's just stacking without drizzle and then just enlarging it in a graphics program. I'm not sure it achieves anything more, but it does work. And the sharpening I found works well for the moon, and I have compared a lot of images of the moon sharpened in AutoStackert with sharpened in Registax, and I actually prefer the ones, for some reason I prefer what AutoStackert is doing on the moon. However, with Venus, I still prefer to use Registax. Martin, have you tried the AutoStackert to sharpening and or drizzle functions and found them useful?
I use the drizzle quite a lot, but just for enlargement, really. I've done a number of experiments seeing if you can get, it's supposed to improve the quality by doing a clever interpolation and filling in extra data. It should be a richer image with more detail, but I've never really found that. It's useful for enlargement, and sometimes it's worth doing it on small planets, Mars when it's quite a distance from the Earth, or Uranus or Neptune. I will often use the 1.5 or 2 or 3 times drizzle to enlarge it, because then it's easier to work on in Registax. Otherwise you get quite a small image. It's hard to work on in Registax with the sliders and see what you're doing. So that would be the benefit of it. But it really is just an enlargement. But I've not used the sharpening.
Well, I have. I've got some images on the screen now of the moon taken just the other day on the 3rd of April of the Sinus Iridum. And this is one that I sharpened in Registax. And this is one that was sharpened by AutoStackert. Well, you get different results because you use different settings, but I thought the AutoStackert did a good job of sharpening that one. That's the unsharpened. That's the unsharpened image of Sinus Iridum. So sharpening makes a big difference there. And that's what AutoStackert produced. I was quite pleased with that one. So
and where are the settings in AutoStackert? Because I've never used it. Didn't even realize there were
settings in AutoStackert.
I think you're breaking up a little bit, David.
On the right, that's not. Sorry. Yes, I will. Find the AutoStackert screen, and in the main AutoStackert window, the one that says "Free for non-commercial use" at the top, there are some settings. There's some drizzle settings down on the lower right, and there's also this above that. in the middle right, there is sharpened. There's an option for sharpened, and it says blend raw in for 20%. That's the default setting, and I haven't tried altering this 20%. You can alter it. So it's blending a sharpened image with presumably an unsharpened image in a certain ratio. So that's where the settings are.
Okay.
Right, are there any more questions?
What I was going to suggest, David, is we perhaps look to finish up by 8:30.
Definitely, yes.
There's one or two which have come through on YouTube. Probably the most one which is quite useful. Someone who's enjoyed it and found a helpful session, but wonders where to find the links because they've not found them all. We can't really put clickable links up on a stream to YouTube, but perhaps would the links be somewhere on the BAA website?
Well, what I'll do, I'll create a page on the equipment and techniques section headed with this the title of this webinar, and put some links in that came up and that I think would be useful. So I'll collect a few links and put them on the BAA website. Any other outstanding questions that I've missed?
I'm not sure if you can answer this quickly, from Joaquin Tapioles. How can you get anything out of the atmosphere of Venus? I have an ASI 120 MC and filter that brings a camera and filter and 47 degrees, I think, or 47. I'm not sure if there's anything you can. So
how can you get anything out of the atmosphere of Venus? The details are subtle. So with one of these processing programs like Registax or Photoshop or the GIMP, you can try sharpening up and exaggerating the contrast on an image and see if you can bring out some of these subtle contrasts. But it is quite an art. It does take quite a lot of trying and quite a lot of experience. You might be in a location where you don't get good seeing very often. And just the focusing, I find, is not a trivial thing. It takes a lot of care. The focuser that I've been using today is a motorized focuser, which the focus can be moved without touching the telescope, and that is quite key, really. It's very hard to get a good focus on an image at long focal length. There's this tremendous magnification factor, and so without the motorized focuser, it's very hard to focus the image at all. You'll just shake the telescope around too much in the process of focusing. So motorized focus part of the setup. And to get that focus accurate, but to actually diagnose particular problems would be difficult without seeing what the questioner has done and quite what stage they are. But I will say that there's a link on the BAA website where people can email me on the equipment and techniques section site. They can send me a specific query, and where people have detailed queries, I'll either answer them or I'll send them to Martin or Damien or somebody who I know can help. And so we'll always try to help.
And perhaps just a final quick question for the last minute. This is from Mike Foylan. What size CCD chip do you use, and do you need cooling?
You don't need cooling for these very short exposures. Cooling really only becomes an issue when you're taking a minute or more exposure. So for planets, no, you don't. It doesn't need cooling, but you might go for a cool camera if you want a general purpose camera. If you want a camera that can do planetary and lunar imaging and longer exposure imaging of deep sky objects, you might want to get a cooled cam anyway. Whether it's cooled or not won't make any difference to images of planets. The size of the chip is really what you can afford, I think. The chip here that I've got on the screen, this Grasshopper 3 camera, I forget exactly what it is. I think it's something like it says here, the maximum size is 20,000, it's 2,000 by 1,500 pixels, roughly. And I think in actual physical size, it's about a quarter of an inch diagonal, about half an inch diagonal, maybe more than half an inch diagonal. That's quite a big chip, but it makes it much easier to get the planet on the chip with a big chip. It makes it easier to find. You can have a slight error in your finder telescope and still get it on the chip. If you've got a small chip, like a 640 by 480 chip, like we always used to use with the Philips 2 cam and the early webcams, it was a nightmare actually getting the object on the chip to start with. So you don't need a large chip. The answer is you can use a very small chip. You can use a 640 by 480 chip because you don't want to gather all this data from the space around Venus. You don't want to gather all that data. That's just wasted hard disk space. So when I actually take the images, I'm only using a small part of the image anyway. But if you want to take larger images, say of the whole moon or the whole sun, with appropriate solar filters, then you might want to go for a larger chip. So obviously the larger chips are more expensive, but you can make do with a small chip, 640 by 480 for planetary imaging, but it is then harder to put the planet on the chip at longer focal lengths. So I'd go for quite a big one personally, if you can afford it. There's no disadvantage to it, and the commonly available ones, yes, and the commonly available ones allow you to adjust the area of interest. So we've gone on a long time here, so I think we'll call it a day now. We've got another webinar next week at the same time, and Andrew will tell you what that one is briefly.
Yep.
And
thank you very much, David. It's a wonderful webinar to see Venus live, and thank you also to Damien Peach and Martin Lewis for joining in the Q&A session, which was another brilliant session. Next week, same day, same time, Wednesday at 7 o'clock, we have Dr. John Mason, Director of the BAA Meteor section, although in this case, he's going to be talking about Sir Patrick Moore, his early life, mentors and notebooks. And this will be part 1 of 2. Thank you very much. And I hope everyone can join us again next week. Thanks again, David, Damien and Martin.
good evening.